Okay, so good afternoon, ladies, gentlemen, students, graduates, postgraduates, and young scientists. I welcome you at our 7th conference on information technologies, telecommunications, and control systems. And I'm glad that I could see so many people today in our virtual room. So yes, due to current situation in the world, we have to conduct this meeting this time, the first time online, but I do hope that we still be able to have good experience. We will find new contacts, create new relations within our scientific society. So I do hope that these 2 days will be very interesting for us. We'll have some fun. I do not want to have this event too formal, so please enjoy it, and please be active, ask questions, communicate with others, because this is the main idea of this event. This is the main idea of our conference. And also, I'd like to thank you, our session chairs, who will be responsible for facilitating the process. We'll have 8 sessions overall, and we have 8 session chairs. So please treat them with respect. And I do hope that this event will go smoothly, and it will be very useful and very productive for all of us. So we'll start exactly at 12 p.m. Moscow time in 3 minutes. And I think authors from first session ready to make their presentations. So we'll have 15 minutes overall. Please take these time slots for you, and let's try to follow the schedule. So I think it's about maybe 10 minutes, 10-12 minutes for presentation, and the rest for QA session. So Dear participants, please use chat in the Zoom to ask questions during the presentation. And at the end, I will ask our session chairs to look through these questions and provide them to presenters. So the process will be something like this. So I think that's all for my welcome speech. And again, I'm really happy that I can see so many of you here. Unfortunately, not in real life, but at least in this virtual room. And let's start the action, I think. So, Hamza, now I give you all the authority. Your session is the first one.
Okay, thank you, Artem. Good morning, everyone. Based on your time zone, good morning, good evening, good afternoon. So let's start with the schedule. So today I'm the session chair. So today I'm the second presenter. So as a session chair, my responsibility is just to switch between the presenters and read the question if you have a question. Also, we have 15 minutes. We should stick with the 15 minutes. So now we can start actually. Now we have the time, so we can start with the first presenter. So so I am the responsible for section 1. So I will ask Mr. Alexander and Mrs. Olga from Ural Federal University to start sharing screen and present.
Good afternoon to everyone. Can you see my screen?
Yes.
Yes.
Do you hear me well? Is the sound good?
Yes.
Good afternoon, ladies and gentlemen. My name is Alexander Zhavoronkov, and the name of my presentation today is Application of Multi-Agent Approach in the Electric Power Control System within the Active Energy Complex. And first of all, I would like to say a little word about us. We represent the Ural Federal University located in Yekaterinburg, Russia. And our major study in field of interest includes simulation, modeling, multi-agent systems, decision support systems, computer-aided software engineering, and finally, integration of all known features. And my personal field of interest is lay inside the energy complexes. Currently, the world practice has formed an approach to the development of electric power systems using the smart grid view. Smart grid is an active adaptive network, is an energy distribution system that contains various control systems, monitoring, and wide use of information and communication technologies. And such a network is actually a cyber-physical system, which is also called CPS, a system consisting of various natural objects, artificial subsystem, and controllers. And currently in Russia, a decree of the government has entered into force. Resolution provided conditions for implementation of a pilot project to create active energy complexes, which is also called AEC. A new model for organizing energy supply to groups of industrial customers based on distributed generation. Here you can see the picture of how such complexes can be look. We have some local electric network and the centralized grid. Such network has one connection point, and each connection point will be equipped with intelligent controllable connection, which is intelligent control system that implement a technical requirements to such connection. ICC, intelligent controllable connection, is a key technological element of the AEC, which provides continuous monitoring of the flow and metering of electricity, as well as regulates production and consumption of such grid. It also includes remotely limiting electricity consumption within the permitted capacity. Here you can see on the next slide, you can see the main functions which such intelligent control system should implement. You should also note that it's not an overall list, but it also includes the majority of secondary functions as well. And the main problem facing the creation of microgrids in Russia is a high load on the dispatchers using the operating mode of the microgrid. And such grids is very different from the traditional power systems. And the task arises of building an intelligent control systems that can work in real time. And the second thing is there are no existing industrial control systems at all in Russia that are using nowadays. Our issues of the near future is to engineer, to develop of such microgrid control systems. The solution proposed for such control systems involve multi-agent system. Multi-agent systems are well suited for monitoring and controlling power grids, are especially for smart grids where communication and distributed assets are intensively present. Here you can see the picture of how the multi-agent system maps onto the real life objects. The real grid have the source, transformer load, and different energy storages. And multi-agent system is provided with some kind of digital digital agents that can repeat the behavior of real-life object. Microgrid control requires flexibility and extensibility, and those are inherent features of multi-agent systems. Because the active energy complex management system is distributed, it is necessary to create a management system architecture that can solve interrelated technological and economic tasks of the microgrid management in real time. It is proposed in our work to develop a distributed control system using an artificial intelligence and multi-agent system methods for solving these problems. In the Russian practice of energy engineering, there are no existing industrial implemented control systems. The next picture shows the main algorithm that should be supported by the ICC. Such an algorithm is implemented jointly by all ICC that include in the microgrid. First of all, the maximum power consumption is set for the entire complex. In the normal mode, the power consumption should not exceed of 25 megawatts. Exceeding the limit is allowed within the specified time limit. For example, it can be a time of 5 minutes. If the excess lasts longer, it's necessary to calculate the power limit of local generators, including the active energy complex. If the generator allows you to increase the power, the generator should increase its power value, and otherwise, if the ICC should calculate consumers that can be disconnected, as well as continuously determine the source of exceeding limits in real time. And the main task of our study is to build the most efficient microgrid management control system that uses multi-agent system, which would be able to implement such algorithms. And the conclusion of the current stage of our study is that the relevance of microgrid will grow in Russia because the pilot project has just begun in Russia in this year. It will require the creation of intelligent control systems which currently do not exist in industrial design. Research continues and control algorithms are being improved. New control models are being developed in the energy sector. And the second conclusion is multi-agent systems are the most suitable framework for creating distributed power systems, as shown in a large amount of scientific material. It's necessary to develop an effective microgrid control system, and further research is aimed at this. So thank you for your attention. I'm ready for asking your question.
Okay, thank you, Alexander. So we have a question on the chat. Are there any implementation examples in Russia somewhere else or developing some such as control system? Is there any implementation examples in Russia?
Mm-hmm. Okay, thank you for your question. I think today is actually no any examples of such projects in Russia, because the project is currently on the stage of launching a pilot project. But I know that there are a few companies, technological engineering companies in Russia, that create prototypes of such control systems, and we get acquainted with the work as well as with the international experience in that area. And I know that some of Moscow Power Institute can do related work in this area.
Mm-hmm. Okay, so the previous question came from Mr. Konstantin. Also, I will ask you a question. This is from me. When you say agent, when you say multi-agent, what do you mean by agent? Agent is a like a part of the architecture. Is it like a control system? Is it like a software?
Okay, thank you for question. When we say agent, we mean some hardware or software entity that can implement intelligent functions. Let me show you the main maybe slide of my presentation. If you see that microgrid, you see a few facilities and power plants that can be situated here. And one agent represents one virtual physical object, and software agent, which is located on some part of hardware, which is distributed over the real grid. Such software agent can execute some code, some program that will run the work of such real objects.
Okay, thank you, Alexander. Is there any questions? Okay, we have a question from Mr. Ivan. What is used at present time instead of this system? What's the current state for like replacement for this kind of systems?
What's the current state of what? Can you repeat this?
What is the current state for such a system? So this is the replacement system. This is the optimal system that it can be applied, but what is current used?
The current use, there are well-known international examples of intelligent control system in energy sector. But in Russia, there are no existing examples. And if you ask for our study, today we are just starting our survey, and our system has a main algorithm. Our idea has a majority knowledge of how such system should work. But it doesn't have any hardware or software application yet. We're just starting.
Okay, thank you, Alexander. Is there any questions? Okay, thank you, Alexander. You can release the screen and we will go to the next presenter, and this is me. So I will ask you guys just for 5 seconds, can you open the camera just for 5 seconds to see some faces? Okay. So yes, you can turn off the camera. So now I will share my screen and we'll start with the second presentation. You can see my screen. Okay, so I will assume yes. Okay, so if you have any questions, please write on the chat. And let's start. Today I will present you one of the first step in my PhD as a student, first year. So today I will present you a paper or a method that I call it pattern matching based scraping for news websites. So my name is Hamza. I'm a PhD student from Innopolis University, and this is my first step in my PhD. So let's start with the problem. So the problem, as you see here, in general, the web have a lot of data, and it's not used. Like I will say, it's not used efficiently, but it's used. One of the main things that a lot of people not used about the web, that the web is source of data. And the problem with the source of, as a source, it's not structured. So if you want to extract some data from the web, you need to create some kind of web scraping process. And when I say web scraping, it's a process to get information as a structured information from the web. So this process based on or depends on three main elements: the HTML structure, the CSS, this is the language that the web is written or the web page is written, and also the dynamic way for naming and the structure for the HTML and CSS. And this is the problem, like generate the solution. And this is the current solution now. We have, in general, if you want to do some scraping or whatever based on the web, so you need to do two things. First of all, you need to build a custom scrapers. And custom scrapers are related to individual cases. So every website have his own like script, and this script can scrape all the information based on that website and based on that structure. And this is, you need resources. Because of that, you need resources, you need developers. And the other thing is the regex or the regular expression. And this is also another like scraping method that can use the regular expression inside the language itself. So you can give some pattern based on that regular expression. But also another problem with this, that you need to define what is the language, what is the expression, and you need to do some mapping. And this is the problem currently now with web scraping. We don't have a general method. We don't have like a general scraper that can work with let's say the sources on the web. So as you see, this is a website, and this is a website for news. And if you can see the image now, you can see that there is a pattern inside this image. And you can go to any news website or article website, you can find that this pattern is like, you can see it again and again. And what is this pattern? The pattern is very easy. The title, always the biggest text by size. And you can see that this is the title. The title is the biggest text in that page. And also the body of the articles is the biggest div from the length. So as you see here, the biggest div have a lot of text or the length of characters inside it. So based on that, we generated some pattern, and this pattern can extract the information from any website. So as you see, our process for the data collection, we have 40 random websites, most of them based on the news. And as you see, this is a sample from this website. We have the title, we have the body, and based on that, we implement, like the current implementation for the scrapers. We used Python as a language. We used Beautiful Soup as a library for scraping, and we have our data collection that the 40 news website. And as you see, this is the code. The code is very simple, because as you see here, the code for the first code snippet, we're searching about the headers, and headers H1 based on Beautiful Soap and based on the HTML, header 1 is the biggest text that you can find it. And you just find it and you will take this text and you will save it and you will take the first one. And also on the another way to find the body, also we have another code, a piece of code. It will go based on the divs and find the biggest length for any div inside the page. And in that set, we have the title and we have the body. As you see from the results that we got, from 40 websites, we have the pattern can be, for example, as the first result, we have 22 websites. We have all of them. We have one header, and we have the header title order. It's the one. So the header is the first one that you can find it. And also we have the biggest div, the length include the body text. So if we search about the inner divs, you can find that this is the biggest div that have the body. And during this experiment, we figured out that this, let's call it, this method is also have like a success percentage for it's 97.5%. From the sample that we did it on it. So also in conclusion, as you see as a pattern mining, in general, when you start thinking about this problem, you think that maybe you can use machine learning or use like some kind of technology. Sometimes you just need to see what's the pattern inside these web pages. All web pages, news and websites, they have these kind of pattern. And this is the thing that we recognize inside this research. And as you see, for news website or articles website, we have the title, header, like the title is the biggest header and the first header, and the div or the body is the biggest, the body of the div that contain the body is the biggest length in that page. As you see, for us as a future work, or we can see also as a weakness in this experiment, we need to increase our data set to include more, and not just news website. We should include more and more like different kind of, for example, blogs and different websites. And also another thing that you can see it in the future work. And this is the interesting topic that we can continue on this research. Try some different concepts. For example, in the e-commerce. In the e-commerce, we have the product listing, and also in the ads listing website. And from these all, you can generate some kind of general scraper for based on the category. So imagine that you have a tool and you just give it the website, and this website, you will define only the category. And sometimes you don't need to define the category, because if you can read the first page, you can define what is the category, and everything will be done automatically without interacting from developers, without any information from, let's say, the structure of the website or any like the problems that we mentioned before for the HTML structure, the CSS namings, and the dynamic between the structuring and also the naming for the website. That's all for me. If you have any questions, I will be happy. Feedback also, I will be happy to answer. So I will start answering. Will this pattern be applied for NLP tasks? Yes. So the one of the questions that we got from Mr. Stefan, for this pattern can be applied for an NLP task. So in the beginning, that what I started, when I started with this research, I thought about like making it based on machine learning. So my scraper will be working on machine learning. And this is that I discovered that in this task, I don't need machine learning. But in general, there is a lot of tries that also, I mentioned this in the literature review. There is some people that they try to mix machine learning with, let's call it with the scraping process. For NLP in general, it's based on the language and the support. For example, what I did it in 3 different languages. And in Arabic, we have the NLP, like let's call it the library in NLP, and it's not very strong. In English, it's the top. And also I used Russian as a third one. So for me, like choosing 3 different languages and make the scraper more general, it was it was better for me to use the pattern, not to use the NLP. But yes, it can use NLP. And if you will work with English, maybe you can also extend this like scraping process to different stuff. For example, you can recognize the data from the title, from the body. You can read the body, and also in NLP you can define, let's say, the structure for even for the body. For the English, that this is also another project that I'm working on it. We are splitting the body for the article based on the context using NLP. So we are splitting to paragraph. So yes, the answer is yes, we can use NLP tasks using this pattern. Any questions? Okay, so thank you guys. Thank you for comments. And so let's go for the next presenter. The next presenter also from Ural Federal University, Mr. Shirokov. You can start sharing screen. Okay. Now we have Mr. Rypalov, also Mr. Rypalov and Shirokov. Anyone is here in the session?
Hello, I'm here. Wait a second, please.
Yes, you can start sharing screen directly.
Desktop. Very glad to see everyone who is present at the meeting. This article was prepared by Sergei Shirokov and lecturer and Alexander Rypalov, students of Ural Federal University. We'd like to talk to you today about dispatching method of incoming events for ERP systems based on analysis of email using artificial intelligence technique. To create a common information space, where departments and divisions of the company can collaborate with each other, companies are implemented ERP systems. That system provides automatic not only production, but business processes related to the budget, finance, tax, human management, and other spheres. In our work, we use platform 1C Enterprise, that is the most popular ERP system used in Russia. Nowadays, there are two concepts are implemented and aforementioned automation systems: BMP, business process management, and workflow, which are interrelated. OneC Enterprise platform contains a built-in business process engine. In general, the following goals are achieved when applying the business process engine, like efficient notification of staff about incoming new task, organization of employees' working process, workflow management, and coordination of work between departments. We are here today to describe a method for solving automatic dispatching problem of incoming events, incoming emails. So today, modern enterprise is facing increased processed information problems. Companies use various information resources, corporate database, application, and office software. Today, email corresponding is one of the main textual communication means in business. Using it to obtain initial data, we can flexibly manage all existing business process in an enterprise. Distribution of incoming events, which is currently implemented manually, increasing number of incoming emails, letters. This is considered as a vital task. The integration of an enterprise automated system with any communication sources is one of the most important tasks. This reduces the loss of information, speeds up the interaction between executors, and increases the overall manageability of the enterprise. Therefore, the integration of enterprise automated system with any communication is the most important task. This reduces the loss of information, speeds up the interaction between executors, and increases the overall management ability of the enterprise. For integration, can be designed as a built-in mail manager or used an external mail program. After data retrieving dispatching task appears, In other words, the distribution of incoming events, which is currently implemented manually. Taking into account the increasing number of incoming email letters, this is considered as vital task. To solve the specific problem, there are three components are used. Email processing queuing is an application program that provides data from user emails. Natural human language recognition, we applied a platform named BotPress based on neural networks. It's mainly focused on natural language recognition and identified for building chatbot systems. Program part of ERP system integrated into the enterprise workflow engine. And it connects to both of mentioned models and received user useful data from them. Let's see the concept of joint interaction we created. In general, the algorithm includes the following actions. New task will be created when a request is received. At the same time, the system recognizes the client by contact information. It also detects the subject of the appeal using artificial intelligence and looks for any connections with previous appeals by references to common task, documents, and other processes of project. Finally, the program determines a role of supposed executor and dispatches the task to the right employee. Let's interact the main functions of the system. Analysis of incoming email. And first function, next, finding relations with previous unfinished task in one business process, automatic creation and distribution of task, editing new objects and documents inside ERP systems, determination of key appeals parameters and link them to the task, and at last, make possible to view full text of appeal and respond it through external email program. For the right operation of the system, we are required the following installed software. First, it's Microsoft Outlook client that must be configured to receive email to a specific address. Application solution 1C ERP Enterprise Management, which is the link between three parts, and BotPress server with language model to achieve complete autonomy of the system. Before starting training the neural network, we identified several categories, directions, and goals. This includes many business processes from categories sales management, document management, product activity, customer service, and warehouse management. Now, all that remained was to train the neural network. The process of creation and training a neural network is realized through the interface of web application without using the program skills. Feature shows an example of training the neural network for processing of a customer order intent. The client order intent is selected on the left panel. The central pane contains statements related to the current intent, and the right pane contains entities or key parameters. The system automatically calculates the number of required examples to display relevant information. The platform extracts information from text and keep it in entities, which it used for the further automatic filling of documents and determining relations with other objects in ERP system. Client application exchange information with BotPress server through HTTP request. The server returns a JSON string of a specific structure that can be processed in a special unit of ERP system. Slide shows an example of the resulting structure where the property contains a list of the most relevant intents with the highest matching index. The intents property includes array with all possible intentions. If the neural network can recognize any entities, they will be replaced in the slot structure. A special external processing unit was created using development framework 1C Enterprise. It's received any process source data from Microsoft Outlook by using a COM object, sends it to the bot processor by post request, and based on the result, creating task for users according to their roles. Thus, it builds an enterprise business process engine. On the feature, we can see the several incoming emails and recognized appeal subject of the one of them as a result of neural network processing. Experimental testing of the system was carried out on samples of emails from the company's business correspondence and corporative table. It contains text of various appeals and results of neural networks work in the form and recognize intent with the matching index. Each line of diagram represents an intent that has been tested. The color of separation of the lines show how the system determined intent as a percentage. Green indicates a correctly defined percentage, orange indicates incorrectly defined intention, and gray means that the system was unable to identify any of the intentions. Based on the obtained results, we can conclude that number of correctly defined intention is 62.5%, 10 correct cases against 16. Considering the fact that during training of the neural network, a limited set of statements was used. In average, about 4 examples were provided for each intention. It's really small amount of examples for neural network. The obtained result can be considered as positive. In conclusion, we want to say that we managed to confirm the fact that it is possible to embed that mechanism into business process engine of the information system and solve the problem practice. In addition, was developed a program model for ERP system based on 1C Enterprise platform and integrated it with external mail application neural network oriented to neural language recognition in practice. Thank you for your attention.
Thank you, Alexander, for the presentation. I have several questions. For the first part, as I understand now, Gmail they're trying to do some kind of machine learning for like the recognition for the text inside the email. So now they are giving you like auto replies based on the content itself. So you're doing the next step. So you're taking and let's say you review the email, you're taking the information from the email, and you will do another step that you will, for example, you will do some redirects this kind of email for the person who should see this email. Am I right?
Yes, you're right.
Mm-hmm. So in this process, is it optional or required to do like this? Like as an employee, should I see that and approve, or it will do like automatically?
Its current state, it's optional.
Mm-hmm. Okay, so it's an optional to see that, and after it you will approve it based on that, because it can lead some problems if it's full automation. It will lead some problem if the method will have like even like small error. You will send an email for not like responsible person or the person who's not responsible about some tasks. This is the first one. The second question is based on the email security. For example, a lot of businesses, especially in ERP system, they have a problem with ERP system that, for example, open source like Odoo ERP. So these ERP are not used, and it's good. It's good for small businesses, but a lot of big companies, they are not working with it because of the problem of the security of the software itself. So as I understand, you have a server, and this server deal with the extension or the application that it will do the reading for the email. Do you have like this issue with the use case that you did it, that there is an external entity that connected to such a system, such as important system like email system in ERP? Do you have this problem?
Yes, we have the problem. We not work on security, but I think it can be. Sorry, I'm sorry for my English.
No problem. It can be resolved in future. It's like a future work, maybe.
Yes, of course.
So for a recommendation, this is also I'm not sure if it can be done, but some kind of ERP system that you can do like the application not connected to a server, so you can do some kind of plug and play for such a software. Because a lot of companies and businesses, they're saying that, okay, we don't give you an information to train your model. Give us your model and we will train our data based on that. So yeah, this is another thing that you can think about it for the security. Okay. Okay, thank you, Alexander. We will go with the fourth and the last one in section 1. Stefan, Mr. Stefan and Sergei and Anton. You can start sharing the screen.
Hi, Hamza. Do you hear me?
Hello? Yes.
Okay. Do you see my screen?
Yes.
Okay. Hello, everyone. As you will see, we have developed a really good approach for many tasks, interactive cloud computing I want to present. And today we are going to go through our current achievements of this scope with the analysis of dynamic systems as an applied task. This can be useful for any researchers. Those tasks involve time-consuming calculations like machine learning and NLP and etc. Today, we will walk through technical issues of dynamical systems analysis, implementation of the Lyapunov characteristic exponent method will be presented. Also, we will discuss software architecture and deployment process and its usage. We will see computing experiment results and state some conclusions as well. And last but not least, we will go over future improvements. The computational complexity of even one experiment with a dynamic system is high. And the study consists of a series of experiments with different initial conditions. The usage of high-performance computing methods is required. When implementing numerical methods, specialized tools like Maple and etc. are used to integrate systems of differential equations. It is difficult to apply traditional high-performance computing technologies on cluster, like MPI and OpenMP. And the series of experiments should not be planned based on just intuition of the researcher, but should be based on strict algorithms. And easy-to-use computational experiment control technology should be also required. So, before we continue, we should shortly state the method for computation of Lyapunov characteristic exponents for the Lorentz system and describe the Maple implementation of Bennett's algorithm. The main goal of this method is the detection of chaotic behavior of a dynamical system. As we can see, the algorithm is based on joint integration of the original system, like Lorentz equation, and 3 subsystems of variations for each extensional coordinate. So, time for interesting question. Why should we use the parallelization for this task? Let's imagine that we are using good hardware and the following software. How much time do we need to complete only one calculation of the Lyapunov spectrum? around 270 seconds. We have 10 independent tasks for one series. And if you have 10 series of calculations, what should we do? Right, we need the parallelization here. So we prepared the following requirements for the system. The first is the ability for a researcher to work with the source code in Maple language, like without any modifications. He also needs the ability to interact with the program in the same way as in the Maple environment, like simplicity attribute. And it is also important to be able to collaborate with our researchers, jointly manage the experiment and use each other's computing resources. Our system contains three main components. The management component is used to generate parallel tasks. It consists of two parts. The first part is a Jupyter notebook that generates the parallel tasks. The second part is a library that allows users to interact with the Everest platform server using the REST protocol. Both components of the system are implemented using the C++ programming language. The management component is deployed in conjunction with the Jupyter Hub server in the DigitalOcean cloud service. An intermediary component is a special program that is pre-installed on the Everest server. The Everest application determines how to handle task parameters that are automatically passed from the management component to the Everest server to call the tasks on the computational component. The Everest application also states a method for transferring the task result from the computing component to management component. The Maple spreadsheet that calculates Lyapunov exponents is uploaded to the Everest server as part of this program. The Everest resource agent represents a computing component. As the resources, we use the VMware virtual desktop service in the corporate cloud of Samara University. According to this architecture, the researcher can work in a browser like easily, so the flow isn't complex. Let's go through the steps how to use it. The first step, we need to get resource token, like login into account of the Everest servers, create resource agent, and save this token. And we should repeat these steps for each virtual or physical machine which will be used. The next step, we should install agent for each virtual or physical machine and put this token from previous step. The next step, we can check a state of the resource agent. We can do it easily, just open settings from Everest service, and we should like get this status like online. The next step, we should configure environment variables for each resource. We should add the path to the Maple executor program as a path environment variable. And the last steps, we can just open Jupyter and see this source code with the implementation and like configuration of our system. So the first step, we can get the application token by running the authentication commands. We can check Maple source code. Researcher can modify this file, like configure parameters, like discretization step, numerical integration methods, and initial conditions. We just need to run calculations. So, and we can get result. We can see results here, or we can check jobs from Everest service. Also, If we want, we can change the task selection algorithm. There are 3 code snippets, redefinition of which allows you to implement the following features, like changing the state of calculations when the task is completed, checking the availability of tasks in the current state of calculations, and new tasks creation operation. Let's also discuss computing experiment results. We run 12 series, 3 series on 1 virtual machine, 3 series on 2 virtual machines, 3 series on 5, and 3 series on 10 virtual machines. Each series consists of 10 independent tasks with different initial conditions. And as we can see, with the most stressful calculation, we got efficiency coefficient is about 90%, which is really great. As a conclusion, we have developed a software package that allows users to automate resource-intensive computational experiments using this method. The novelty of the method, which provides an advantage over more traditional approaches, is the ability to use together the enterprise desktop grid computing and modern approaches to computing, including web systems and cloud web services. We tested the technology in the corporate cloud servers of Samara University. Our experiments have shown that up to 10 virtual machines can be used together in a single computation with an efficiency of about 90%. Solving a real optimization problem from the field of dynamical systems analysis, we have shown the applicability and usability of the proposed architecture. And also some words about future improvements. We have plans, we have the following plans, like add decentralized global storage. It can be based on IPFS protocol. Also, we want to implement resource management for predefined resources. It can be done by Kubernetes cluster. And also, we want to create common user interface with managing tools and different roles like researcher, administrator, and etc. So, thank you very much. If you have any questions, you are welcome.
Okay, great presentation. Thank you, Stefan. I have 2 questions. When you mentioned the computational tasks and you mentioned C++, is it also supported for different languages?
We created like tools, like you can add any programming language, any implementation, and we can edit, like customizing resource agent. And if you can create like execution file, we can easily use it.
Mm-hmm.
So the core service is implemented like with C++.
Mm-hmm. Great. Actually, it's a great tool. I'm saying this because we had a project and we have this kind of problem for the computational tasks, for example, related to Python, machine learning. And we have this problem that we don't have resources and we need to do some kind of distribution for the tasks based on that. We used multiple methods, but this method can work actually.
Yeah, I understand.
Mm-hmm. Yes, thank you. And also another question related to IPFS. So you mentioned that you will use IPFS as a decentralized storage or computation?
Decentralized storage.
Mm-hmm.
We created like the model for decentralized calculations, but we also need to apply like some distributed storage. And now we have plans to use like to be based on IPFS protocol.
Mm-hmm. Mm-hmm. Okay, great vision. Thank you, Stefan. Thank you for this great presentation. So we are finishing in section 1. So yeah, thank you everyone. And now I will give the lead for Artyom.
Yeah, thank you, Hamza. Thank you. It was really good, really great session. And I think we will not make any gap between session 1 and 2. So Anna, are you ready to start the session too? What do you think?
I think I'm ready, but will our participants here?
Yeah, I
So,
think
start?
8 minutes, they should be here already. So Ivan, Ivan Kosternoi, I see he's at least in this room, and Vladislav Katz, I don't know whether he's here or not. Yes, he's also here. So I do hope that we're ready to start. Yeah, and maybe after the session 2 we'll make a short break. So, but now I think we could start right, like without any delays.
Right.
Okay. So if you're ready, you're welcome to start.
Thank you, Artyom. And hello, everybody. I'm glad to see you all on the section. And we will start with a report performed by Ivan, Kosternoi, Olga, Kokorina, Anna, Romanova, and Semyon, Rudyi. Please, you're welcome to share a screen and present the report.
Thank you. Do you see my screen?
Yes.
Well, hello everyone. My name is Kosternoi Ivan. I am a second-year PhD student at ITMO University. The topic of my report is a single-phase ion trap with cylindrical zero potential surface. First of all, ion traps were invented by Wolfgang Paul in the 50s of the 20th century. Ion traps are designed to hold various charged objects in space without physical walls, which makes it possible to use the trap to study an object, its properties, the object's interactions with the environment, and so on. Currently, traps are widely used in various fields of physics. The most important and widespread applications are quantum computing, atomic clocks, and mass spectrometry. The purpose of mass spectrometry is the qualitative and quantitative analysis of the substance. Roughly speaking, mass spectrometry allows you to split a biological cell and find out the component composition of the cell. The design of the trap depending on the area of application. The left side of the slide shows the three-dimensional power trap. Here, the particle is confined in the center of the toroidal electrodes and between the end cape electrodes. These traps often used in atomic clocks, for example. On the right, you see a schematic representation of a surface trap. A feature of such a trap is that it can be made according to PCB manufacturing technologies, that is, with high manufacturing accuracy and small dimensions. The confinement of a particle in the presented trap occur above the central electrode here. Such traps are common in quantum computer science and quantum computing. On the left, there is a standard and first quadrupole trap. It consists of 4 rod power electrodes and N-cape electrodes. An AC voltage is applied to 2 opposite electrodes. The other 2 are grounded and a DC voltage is applied to the N-cape electrodes. Thus, the particle is trapped between the electrodes in the center of the trap. A linear mass filter, which is a linear trap without N-cape electrodes, as shown in the slide to the left, is required for mass spectrometry application. So, the accuracy of the method strongly depends on the shape of the field. The effective potential must be as close as possible to a rectangular well to increase the accuracy of the determining the mass and charge. An infinite number of electrodes are required to obtain an ideal rectangular well, what is impossible. Currently, the maximum number of electrodes has the 22-pole trap, where an AC voltage is applied to the electrode through 1. Thanks to this, modern mass spectrometers can achieve an accuracy of 4 Dynamical places Daltons. However, the total error increase by non-perfect system with increase in the number of electrodes up to the point that the mass filter does not work as it should. Field deformation can occur for various reasons. The most common are displacement, curvature, or general non-visibility of electrodes. Because of this, deviation of the effective field arise. The figure shows the effective potential of 22-pole trap. The solid line represents the theoretical results for an ideal system. The dots are experimental results. As you can see, the real effective potential is deformed, which can be caused by displacement of the electrodes, the irregular shape, or bending. You can reduce the number of electrodes to reduce the total error. However, then the order of the field will decrease. In our previous work, we demonstrated that the fields of a 4-electrode trap can form a field corresponding to an 8-electrode trap, as shown on the slide. That is, 4 electrodes are needed, not 8, to obtain an octuple field. This effect is achieved due to the supply of an IC field in phase to all the electrodes of the trap, which is shown in the figure on the left. However, no theoretical results were obtained with experimental implementation. The slide shows that 3 stability regions were obtained instead of 1 trapping region in the center of the trap. This effect also is a manifestation of field deformation. The reason for this is that the setup was installed on a grounded optical table, that is, the presence of a grounded shielding surface on only one side deforms the field, which is confined by math modeling. The slide shows how you can neutralize this effect. Leaving as before the general mutual arrangement of the elements of the experimental setup, it is necessary to add a shielding grounded surface around the trap, as shown in the slide on the right. Such a simple and elegant solution will allow to obtain the ideal perimeter field corresponding to that of the octuple trap. The slide on the right shows a comparison of the effective potential of an octuple trap of the standard implementation and our implementation of a 4-electrode trap with a single-phase electrode supply. The red line shows the ideal quadruple effective potential, and blue dots numerical simulation of the effective potential of a single-phase trap. The green line shows the range where the deviation between the potentials is less than 10 to the power of -10. Thus, it is shown that an octuple field configuration with a smaller number of electrodes can be obtained. Such a solution will help to reduce the total error, which will make it possible to obtain a field of higher orders with less difficulty. Thank you for your attention. I am ready to answer your questions.
Okay, thank you. Have the audience any questions? Please feel free to ask. Well, and I have understood you developed some electrical device, yes?
Yeah.
Okay, and can you list some advantages of this device when comparing with other ones with some functionalities?
Its device can be used for mass spectrometry. For example, you can destroy the biological cell through throw these components of resulting destroying throw through the trap, and with some devices can determine which which materials, which components was in this biological cell. So for example, some viruses, some I mean, like
it's a very topical theme, yes?
Yes.
Very interesting report. Thank you. Any question, please? Well, if no, then thank you, Ivan. And we are going to the next report presented by Vladislav from Moscow State University of Civil Engineering. Vladislav, you're welcome to share on your screen and present the report.
Hello, dear colleagues. Yes, So can you see my screen?
Yes, yes, Vladislav. Okay.
Fine. So my name is Vladislav. I'm from Moscow State University of Civil Engineering, and my topic is about structural health monitoring systems of construction facilities, and its enhanced machine learning training approach. So technical condition diagnostics of construction